Okay, so today we are going to discuss some entry test questions which are related to groups and logic. So let's get started. Before discussing the questions, I would give you a quick idea about some of the important topics. And if you are interested in knowing every topic in detail, for that you have to register for our live classes. Okay. So for now, let's get started. Okay. So since today we will be discussing some logic questions, for that we need to know a few tables, right? So by this way or the other, you have to learn these tables, okay? So you can use different tips, different tricks, but for solving questions, you should know these tables. These tables should be on your fingertips, okay? All right. So, and this topic is very easy, so don't worry about it, okay? So the very first table is the conjunction table. All right. So this is the conjunction table. Okay. And this is the statement, right? So we have P, Q, P, Q, and think of it as P intersection Q. Because like if you convert this logical statement in sets, it is equivalent to this, right? So just think about it as intersection, right? All right. So now the table is saying that this statement is true whenever P and Q are true, right? So P and Q are two conditions, two statements. It could be anything. And then we have this third statement, right? This third statement is going to be true if both P and Q are true, right? Then the statement can be false if Q is false and P is true. And again, it would be false if P is false and Q is true. And it would be false again if both of these are false. So don't worry if you are not being able to understand it this way. When we solve questions, you will understand it 100%. Okay. For now, just think of P, Q, and this P intersection Q as three statements. Okay. Three statements. And this big statement would be true if P and Q both are true, right? This is what one is saying. Otherwise, it would be false, right? So in this table, we have four situations, we have four conditions, okay? Think about things this way. This is the third one, and here we have the fourth one. So only the first condition is telling us that P intersection Q is true, and that is possible when P and Q both are true, right? When this and this, these both are true, only then this statement would be true. Otherwise, it is false. It is false. It is false. It is false when both are false. It is false when either of P and Q is false, right? Here Q was false, this was false. Here P is false, so again this is false. And when both are false, P intersection Q is false, right? So I hope it is clear. Just know this table, just understand this table, just learn this table somehow, and you will know that how are we going to use this in our questions, right? So this is basically the conjunction table. Whenever we have this sign, we call it conjunction. And whenever we have this sign, we call it disjunction, right? So similarly, again here we have PQ and P union Q. In sets, this statement right here is equivalent to this, right? This is why I'm calling it union, but it's just a logical statement, right? And these tables are used for solving questions. All right. Now just know that here P union Q, or this last statement, is true when both are true, when both P and Q are true. It is again true when P is true and Q is false. And it is again true when Q is true. So P union Q, like in sets we see it this way, it is going to be true when at least one of the statements is true, right? So when P is true, this would be true. This is true. When Q is true, this is again true. And when both are true, obviously it would be true. It is only false, it is only false, it is only false when both P and both Q are false, right? All right, so it's just a table. All you need to do is just learn this table and you will get to know shortly that how this table would be used, right? Okay. All right, so so far we have just discussed two tables. Now we are going to discuss third type of a table, which basically is the P implies Q table. All right, so for this table, you should know that this is a statement, and in maths, we call it P implies Q, right? Now, this statement is true when P and Q both are true, and this statement is true when when Q is true, right? So again, we have four conditions, we have four cases. Cases is the appropriate word here. So look, P implies Q is true in the first one, in the third one, and in the fourth one, right? So in the first one, we have that both P and Q are true, right? When both P and Q are true, this whole statement would be true. Now, when P is true, I'm at the second condition. When P is true and Q is false, this would be false, right? Now, when P is false and Q is true, this statement would be true, right? And when both are false, when P is false and Q is false, this would be true, the fourth condition, right? So again, by understanding it or like just learning it directly, all you have to do is you should know this table. Like these tables should be at your fingertips, okay? And we have some other tables as well, but obviously I cannot explain anything like this. So if you're interested in more content, you need to register yourselves for our live classes, just so you are able to learn and get a better idea of how things are, right? Because like for these videos, we only have some specific time where I record them. But for detailed discussion, for detailed lectures, you need to register for our live classes, which are online as well. Okay. All right. So far for these questions, which we will be doing today, I will give reference to these three tables time and again for solving those questions. So obviously in your NET or LCAT, like if you're applying for LUMS, NUST, GIK, FAST, if you come across such questions, you need to know these tables. Only then you can solve those questions. All right. So we are done with the tables, right? Now again, we have the last thing which you should know, and then we will start discussing the questions. So the last thing is that again, this is a statement. This statement means P implies Q. The converse of this statement, the converse of this statement is Q implies P. Okay. All right. Then the inverse of this statement, that P implies Q, is minus P implies minus Q. And then contrapositive of this statement is that minus Q implies minus P. Okay, so like apparently these things look difficult, these things look a bit different, especially if you are in your A levels. Like we do not study such things in A levels. I myself studied all this when I was applying for NET, when I was applying for NUST, and when I was preparing for NUST entrance test. At that time I came across this, and then when I did my bachelor's in maths, then I had a proper idea of what these things are. Okay, so this might be new for the Cambridge students, but it's totally fine. You should just know these things, right? If you have P implies Q, this statement, the converse would be Q implies P. Like this statement which is coming after the arrow is coming in the beginning, right? Then if you have P implies Q, the inverse is just like the statement itself, but you have minus signs now, okay? All right, so I'm just giving you some tips for learning this. And then if I talk about the contrapositive statement, which is P implies Q, again we have like Q was here after the arrow, and in the contrapositive statement, it is before the arrow. And then we have P, which was initially before the arrow, now it's after the arrow with minus sign, right? So you have to learn it whatever way you are comfortable, just learn it, okay? All right, so these are some tables which we will be using for our questions. All right, now let's talk about the questions.